So let's go ahead and take a look at the following graph. And we are asked to find the equation of the circle. Well, I need to find the center first. So here is a diameter. Here is another diameter. So the center of the circle seems to be here, where x is -3 and y is 2. So that's the point. Now we need to find the radius. So here's -3, 2. What is the distance from the center to the end of the circle, the edge of the diameter? Let's count them. 1, 2, 3, 4 that way. 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 So it looks like the radius is 4. So radius is 4, diameter is 8. Fine. Now what is our general form for a circle? So if the center is h comma k and the radius is r, our equation for the circle is x minus h squared plus y minus k squared equals r squared. It would be nice if you would know why, and you could think about the distance formula to help you develop that argument. But here I have the center is -3 comma 2. So in my example, h is -3 and k is 2. So to get my equation, and r of course is 4. So x minus h would be x minus -3 squared plus y minus k plus y minus 2 squared equals r squared equals 4 squared. And we'll rewrite x minus -3 as x plus 3 squared plus y minus 2 squared equals 4 squared is 16. So let's take a look on Desmos and see if it matches with what we thought. So remember, this is what we want it to look like, right? Center -3, 2 with a radius of 4. So let's ask Desmos to graph this for us. X plus 3 squared plus y minus 2 squared equals 16. And sure enough, -3, 2 sure looks like the center. And the distance from there, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, looks good. Now, there's one more thing we can do with this. So this is in the form that helps us determine the center and the radius, but we can also rewrite it in, some might say, a simpler form. I'm not sure if it's simpler, but we can rewrite it another way by multiplying out these things. So I can multiply out x plus 3 squared, which of course means x plus 3 times x plus 3. X plus 3 here, x plus 3 there, x times x is x squared, plus 3 times x is plus 3x, plus 3 times x is plus 3x, plus 3 times plus 3 is plus 9. That's x squared, 3x, and 3x plus 6x plus 9. Y minus 2 squared, same thing, y minus 2 times y minus 2. Y minus 2. Y times y is y squared, -2 times y is -2y, -2 times y is -2y, -2 times -2 is +4. So I get y minus 2 times y minus 2 is y squared, minus 2y minus 2y minus 4y plus 4 equals 16. And sometimes it's written this way. So we have x squared plus y squared first, then plus 6x minus 4y. They're not really like terms. And then I have plus 9 plus 4, so I have plus 13 equals 16. It can be written that way, and I even could subtract 16 from both sides if you want it to equal 0, or I could subtract 13 from both sides if you want it to have all the numbers on the other side. So here is an equivalent form for this. X squared plus y squared plus 6x minus 4y minus 3 equals 0. And let's jump to Desmos to show that this equivalent form really is the same circle. So we have that circle up there. We've drawn what we think is an equivalent form. X squared plus y squared plus 6x minus 4y minus 3 equals 0. I'm going to turn these things off and see if they're the same, equals 0. So the red circle is the one that I just drew. The purple circle is the one that I had drawn previously. You can see that they're the same. And the center is, of course, -3, 2.